The science of climate change. The greenhouse effect is essential for life on Earth, as it acts like a natural blanket that maintains the planet's temperature at a suitable level. This process occurs when gases in the atmosphere, such as carbon dioxide, CO2, methane, CH4, and nitrogen oxides, NOx, absorb part of the solar energy that reaches Earth. These gases retain heat, allowing the surface to stay warm even at night when the sun is absent. However, human activities, such as burning fossil fuels and deforestation, have increased the concentration of these gases, intensifying the greenhouse effect. This increase causes abnormal warming in the atmosphere, known as global warming. As more heat becomes trapped, global average temperatures rise, leading to significant climate changes such as glacier melting, rising ocean levels, and extreme weather events. The human causes of the increased greenhouse effect are primarily linked to industrial growth, urbanization, and agricultural practices. Burning fossil fuels like coal, oil, and natural gas to generate energy and power vehicles is one of the largest sources of carbon dioxide, CO2, emissions. Additionally, deforestation, especially in tropical forests, reduces the number of trees that could absorb CO2, increasing its concentration in the atmosphere. Intensive agriculture also contributes significantly. Methane, CH4, is released in large quantities from livestock farming and rice cultivation, while nitrogen oxides, NOx, are emitted from fertilizer use. These gases intensify the greenhouse effect, disrupting Earth's climate system and leading to global changes, such as an increase in extreme weather events and ocean warming, which affect ecosystems and populations. Since the late 19th century, the global average temperature has risen by about 1.1 degrees Celsius, with the warming rate intensifying over the past decades. This increase is largely driven by the excessive release of greenhouse gases from human activities, such as fossil fuel burning, deforestation, and intensive agriculture. These gases create an insulating layer in the atmosphere, trapping more heat and making the planet's natural cooling more difficult. This accelerated warming has significant consequences for global climate. It contributes to the intensification of extreme weather events, such as heat waves, severe droughts, and torrential rains. Additionally, it affects glacier melting and the thermal expansion of oceans, resulting in rising sea levels. Global temperature changes threaten ecosystems and biodiversity, altering habitats and putting various species at risk, in addition to impacting human life and health worldwide. Global warming has accelerated the melting of glaciers and polar ice caps at an alarming rate, directly affecting ocean levels. This melting occurs in regions like Antarctica and the Arctic, where rising temperatures are reducing large ice masses that previously remained stable over centuries. As a result, sea levels rise, directly threatening densely populated coastal areas and small islands at risk of disappearing due to water invasion. Beyond its impact on human communities, polar ice melt destabilizes sensitive ecosystems. Species that depend on ice, such as polar bears and seals, face difficulties surviving as their natural habitats shrink. This warming process also affects ocean and climate currents, which are vital to maintaining global climate balance. The continuous loss of polar ice not only threatens biodiversity, but also makes it more urgent for global actions to reduce greenhouse gas emissions and mitigate warming. Global warming intensifies the occurrence of extreme weather events, making them more frequent, intense, and unpredictable. As the average temperature rises, the climate responds with greater volatility, manifested in stronger hurricanes, prolonged droughts, devastating floods, and increasingly large wildfires. These phenomena impact millions of people, destroying homes, infrastructure, and entire ecosystems, as well as causing enormous economic losses. Hurricanes, for example, gain strength over warmer oceans, resulting in more powerful and destructive storms when they reach coastal areas. Rising temperatures also reduce soil and vegetation moisture in various regions, increasing the occurrence of wildfires and severe droughts that affect agriculture and drinking water availability. Floods, on the other hand, are exacerbated by heavier rains that overwhelm drainage systems and leave vulnerable communities submerged. These extreme events not only threaten lives, but also require urgent and resilient responses to mitigate their impacts and protect populations worldwide. The increase in atmospheric carbon dioxide, CO2, affects not only the air we breathe, but also the oceans, which absorb about a third of this excess. When CO2 enters the water, it reacts to form carbonic acid, increasing ocean acidity, a phenomenon known as ocean acidification. This process alters the water's chemical balance, making it less hospitable for many marine life forms. Acidification harms organisms that rely on calcium carbonate to form their shells and skeletons, such as corals, mollusks, and some crustaceans. In more acidic waters, these organisms have difficulty growing and reproducing, directly threatening coral reefs and the biodiversity they host. Since corals provide habitat and protection for many species, their degradation affects the entire marine food chain, impacting everything from small fish to larger predators. Additionally, human communities that depend on fishing and tourism also suffer the consequences of acidification, which compromises essential ecosystems and marine resources that sustain millions of people worldwide. Biodiversity loss is one of the most alarming consequences of climate change and environmental degradation. As global temperatures rise and natural habitats are destroyed or altered, many species struggle to survive in conditions for which they are not adapted. This imbalance causes various species unable to migrate or adapt quickly to face extinction, while others suffer from habitat fragmentation and degradation. Species extinction triggers a cascading effect on ecosystems. Each species plays a unique role, whether in pollination, pest control, or soil maintenance. When a species disappears, the entire ecosystem suffers the impact, reducing its ability to withstand changes and regenerate. Biodiversity loss weakens nature's resilience, making ecosystems more vulnerable to diseases, pests, and additional environmental changes. Moreover, many resources we rely on, such as food, medicine, and clean water, are directly influenced by biodiversity. Preserving life's variety on the planet is therefore essential not only for environmental health, but also for the well-being of future generations. Climate change is radically transforming agriculture, affecting both food production and quality. With shifting seasonal cycles and unpredictable rainfall, essential crops face adverse growing conditions. In some regions, rising temperatures and prolonged droughts impair plant germination and yield, while in others, intense rains and floods destroy crops and deplete soil nutrients. These variations impact agricultural productivity, consequently reducing food supply, which raises prices and makes access to basic products difficult. Farmers, especially those with small properties, are the most vulnerable, as they often lack the resources to quickly adapt to these changes. Food insecurity is becoming an increasing reality, affecting millions of people, especially in regions already prone to hunger. Additionally, the need to adapt to new climate conditions may lead to intensive pesticide and fertilizer use, which can further degrade the soil and pollute water resources. To address this scenario, new agricultural practices, such as cultivating more resilient species and water conservation techniques, are essential to ensure food security in an increasingly unstable climate. The albedo effect is a fundamental mechanism for regulating Earth's temperature, as it describes the ability of surfaces to reflect sunlight back into space. Light surfaces, such as ice and snow, have a high albedo, meaning they reflect much of the solar radiation, helping to keep the planet cooler. This process is essential for climate stability, especially in polar regions, where vast ice-covered areas act as natural mirrors, reflecting much of the solar energy. However, with rising global temperatures, these icy surfaces are melting at an alarming rate, exposing dark areas such as rocks, soil, and oceans. These surfaces have a low albedo and, instead of reflecting light, absorb more heat, intensifying local warming and accelerating further ice melt. This positive feedback cycle exacerbates global warming, making it an increasingly difficult process to contain. The impact of reduced albedo goes beyond polar regions. Rising local temperatures affect air currents and global climate patterns, contributing to glacier melt in mountains and altering seasons. Preserving ice and snow areas is therefore crucial to moderating the albedo effect and mitigating global warming, in addition to maintaining the climate balance that sustains life on the planet. Action and mitigation against climate change are urgent and demand a coordinated global effort focused on sustainability and transitioning to renewable energy sources. Promoting the use of clean energies such as solar, wind, and hydropower is one of the most effective strategies to reduce dependency on fossil fuels, which are the main sources of greenhouse gas emissions. These renewable sources not only help reduce pollution, but also promote the creation of low-carbon economies, more resilient and less vulnerable to price fluctuations and energy crises. Additionally, reforestation and forest conservation policies are vital for sequestering carbon in the atmosphere and preserving biodiversity. Healthy forests act as the planet's large lungs, absorbing CO2 and helping regulate the climate. Sustainable agricultural practices such as soil management, crop rotation, and controlled fertilizer use are also essential for reducing emissions and preserving long-term soil fertility. Emission reductions are not limited to government policies, but involve large-scale behavioral changes. This includes encouraging public transport, saving energy, conscious consumption, and reducing waste. Environmental education initiatives and community engagement are equally fundamental for building collective awareness and fostering sustainable practices. Only with a global commitment and collaboration between governments, companies, and citizens will it be possible to mitigate the impacts of climate change and build a safer, healthier future for future generations. The science of climate change shows that the problem is complex, but also points to solutions. With the right knowledge and actions, we can still slow down these changes and protect the planet for future generations.